Welcome everyone to the Lab of 1-4. Today, I'll be talking to you about the atomic theory.
Will we get to blow stuff up?
Is it lunch yet? I need to go to the bathroom.
This is going to be a long day, isn't it? Okay, let's start this from the beginning then, shall we? It all started with Democritus and his model.
Wait, who's this democracy dude? And why is his model just a boring old circle?
I think you mean Democritus?
You're a wizard, Cat.
Wowee!
Anyways, Democritus developed the concept of the atom, tiny indestructible things that make up all matter in the entire universe. Democritus actually focused more on reasoning rather than the science of it, unlike John Dalton. John Dalton actually did research unlike you two and Democritus. So technically, this boring model is not Democritus's, but John Dalton's as well.
Oh yeah! Hole-in-one! Go sports!
Moving on, we'll talk more about John Dalton in a bit. First off, I'll inform you two more on Democritus.
So, does he support democracy or what?
Democritus proposed his atomic theory around 400 BCE in Abdera, Thrace. He theorized that if you break an object down enough, it will become an indestructible, microscopic thing called an atom. Next up, we have good old Ben Franklin.
The feeling of freedom, seeing the light, it's Ben Franklin, the key and the kite. You see it, right?
Ugh!
Yes, Ben Franklin was best known for finding the key with the kite. Franklin hypothesized that lightning and electricity were connected and that metal objects can be used to jar away the lightning from the homes and other buildings. Franklin wanted to use a conductor and check the clouds with it, but it was too high to check and gave up on that experiment. Instead, in June 10th, 1752, Philadelphia, Pennsylvania, it was supposed that Ben Franklin performed his famous kite flying. During a thunderstorm, Franklin waited under a shelter and flew a kite and tied a key onto it. When lightning struck it, the electricity traveled to the key, and the charge was then collected in a Leyden jar. Later on, Franklin found the charges in the atoms and discovered the positive and negative charges and named them that.
Wow.
Did you actually listen to this?
No, I was just saying that because it was really long.
Yeah, I wasn't paying attention anymore. I thought this was still about the hit Broadway musical Hamilton.
No, I'm talking about the timeline of the atomic theory.
If it makes you feel any better, you're getting paid for this.
I'm not. The lab doesn't have enough funding, so they cut off paying me.
Oh, never mind then.
Now, we can move on to John Dalton, the scientist I previously mentioned when I was explaining about Democritus.
I still think it should be Democritus, but whatever.
That just sounds like a disease.
John Dalton progressed Democritus's atomic theory, but proving it with actual experiments. Dalton added on to his theory by discovering that atoms from one element can be changed into atoms of a different element with experiments of evaporation.
Ooh, do we get to do a lab on evaporating things?
What? No, just listen. In 1803, Dalton wrote an article for the Manchester Literary and Philosophical Society with his theory. This was super important towards the atomic theory because, well, it basically is the reformed version of it. Finally, we can get to Niels Bohr. I don't even know if you guys understand any of this, but whatever. Personally, I find that Niels Bohr was very boring. Don't you guys get it? His last name is Bohr, and he's very boring.
No, we got it. It was just a horrible joke.
Yeah, it wasn't even clever.
Ha! You suck!
Kathleen, go to the corner and wear your dunce hat again.
Can I get one too?
No, sit down and listen. Sorry about that. I lost my cool.
You were never cool to begin with.
He thought he was cool!
Just listen to me for a few more minutes and then you'll get candy. Okay, can I start now?
Yeah, but if you're lying about the candy, we'll be sad.
Yeah, whatever. Anyways, Niels Bohr was known for his contribution to the quantum theory, as well as his research on the structure of an atom. He created his Bohr model in the time period of 1913 to 1916. When he was creating his new model for the structure of an atom, he used the quantum approach. He stated that electrons orbit the nucleus at specific distances, and each level has a different energy value that goes along with it. And when an atom absorbs energy, the electron moves to a higher energy level. Then, when it loses energy, it releases the energy in the form of a photon. One of his main insights was that an atom cannot absorb or emit energy at just any level. The energy is either absorbed or emitted in small amounts. Did you guys get all that?
I think?
Ah, yes. Energy.
Hey, EJ, how's it going, man? How's chemistry? How's the chemistry going, man?
Sean, why are you even here? Get out. I swear, if you don't leave right now, I'm gonna...